Putting an optimization problem together in Excel requires that you first understand the math, as given on page 118, and then understand how to use a solver in Excel to do the math for you. The purpose of the math is to choose a cost-minimizing location for placing a new production facility or warehouse facility. So that's our objective. The mathematical phrase on 118, shown here on the screen as equation 1, states the objective. We are trying to minimize the sum as I goes from 1 to m of f sub I times y sub I, plus the sum as I goes from 1 to m, the sum as j goes from 1 to m of c sub I j and x sub I j. The statement in equation 1 represents the total cost of doing business at all locations, a calculation that each of you should be acquainted with. The first sum, the sum over I from 1 to n of f sub I y sub I, represents the fixed costs. In the spreadsheet, the fixed cost for each potential location is in dark blue. Here, and again here. The contribution of fixed costs in equation 1 depends on if we open a new plant. We know that because it depends on I, which we're choosing a new plant. So f sub I represents an arbitrary choice of location from the set of all possible locations. So f sub I, like I said, is just an arbitrary, it's the ith one, not f1, that would be the fixed costs in North America, not f2, that would be fixed costs in South America, and not f3, that would be fixed costs in Europe, and so forth. An easier way to think and track these locations is numerically. So let I equal 1 be North America, I equals 2 be South America, so on and so forth until I get to I equals 5, which is Africa. Numbers are not necessary for an index set, but they are certainly more convenient. Associated with each fixed cost is a binary variable y sub I. This variable only takes one of two values, 0 or 1, hence the word binary. Note that if y sub I equals 0, which means facility I was never built, then location I's contribution to fixed costs are 0. Essentially, they wash out of the equation. So if plant I is not built at location I, then y sub I equals 0. If a plant is built at location I, then y sub I equals 1, and the fixed costs at location I do contribute to overall cost. All of a sudden they become some positive number. Finding out what value y sub I will take is part of the problem we're setting out to solve. So y sub I is a choice variable. Get it? We're making a choice. In Excel, I have initially set the choice variables y sub I to 0. Excel will choose, that's part of the problem it's solving for us, at what will be 0 and what will be 1. As with potential facilities, sites, the actual location of each market where we sell our product is indexed. Unfortunately, in this problem, the markets where sales occur is over the same set of continents: North America, South America, Europe, Asia, and Africa. I say unfortunately because an arbitrary j could have the same name as an arbitrary I. The double sum in equation 1 describes the variable cost of doing business. So, for example, C sub ij represents the cost per unit of a product produced at facility I and shipped to market J. In Excel, all of the C sub ij are in the light blue box, which I just highlighted. So the number 117 in the second row and first column is C sub 2, 1, representing the cost of producing 1 unit of product in South America, I equals 2, and shipping it to North America, J equals 1. So how would you interpret the number 59 in the fourth row and fourth column? That is C sub 44. We are trying to figure out how much to produce in facility I and ship to market J. This X sub ij. It is another decision variable. Excel will help us make this decision. So I have listed all potential X sub ij's, and I have set them equal to 0. It's going to start at 0, and then the Excel is going to work to decide how much to produce at each operating facility. Now the constraints. Inserting constraints is like building a mathematical fence, which we cannot go beyond or get out of, depending on if I'm minimizing or maximizing. The first constraint is a constraint on demand, and it reads, the sum as I goes from 1 to m of X sub ij, remember that is the amount of product going from facility I to market J, has to equal the demand in market J. And this has to be true for each market, J equals 1 through m. So in our case, that would be 5 markets, so J would be 1 through 5. In Excel, we have to, or we do arrange that constraint a little differently. It's going to be the demand in market J minus the sum of the production across each of the production facilities that will be shipped to market J has to equal 0. So I just did a little algebra. All I did was subtract this sum off of both sides of the equation, which left one side of the equation equal to 0. This will make Excel easier to work with. The demand in each market J would have to be estimated elsewhere and brought to this problem, much like F sub I, the fixed cost, and C sub ij, the variable cost per unit. In our Excel example, there are 5 estimates of demand. Let's go to Excel. One for each market, and they're given in the dark green box in the upper set of numbers. So let's try to interpret the mathematics written back here. The math in equation 3 says the demand for the product in market J, that's D sub J, minus the production that occurs across all plants, the sum over I, and sent to market J must fulfill all the demand in market J. We must meet it. We can't be not creating product, leaving people hanging. The next constraint is a constraint on our capacity. It reads the sum as J goes from 1 to m of X sub ij. Notice there we are again with that production number, this number that Excel is going to help us find. This time though we're summing across all markets, so J is going from 1 to m. And what this constraint says is that the production across all markets and the capacity of some plant or facility at location I has to be non-negative. So I have a capacity. No matter what I create, see, I have a capacity. If I build a high capacity plant, I can produce 20 million units. If I have a low capacity plant, I can produce only 10 million units. So I have some sort of a restriction on my capacity. The last 2 constraints are relatively easy. The first constraint is given here. It says y sub I is out of this set. It's either 0 or it's 1. Which, again, that's the reason we gave it the name binary. It only is one of those 2 numbers, 0 or 1. The constraint in equation 6 says that If I take a value of 0, we did not build facility I. If it takes a value of 1, we did build facility I. And again, over here in Excel, my Y sub i's are down here in this light blue box in the lower box of numbers. And Excel will work to choose these numbers. Finally, the non-negativity constraints, given over here as x sub ij greater than or equal to 0. We add this constraint to Excel and have done so already right here. There's all of my x sub ij's. I've initialized them at the value of 0. Excel will help us choose those values. So this explains the math on page 118. Let's go and see what we can do about using Excel to solve the math. First thing you've got to do is you have to turn on the solver that Excel has built into it. It's not something that is just on. So you would go to File, come down this left hand side and find Options. Once this box comes in, choose Add-ins, and then down to the bottom it says Manage Excel Add-ins. Just push Go and this little box appears. Make sure there's a checkbox next to Solver Add-ins and then click OK. Now to find the solver, go to the Data tab, and solver should be way over here on the right. This is something we're going to use to solve our problem. But before we can use Excel to solve our problem, we have to make sure that every constraint and the objective function are explicitly spelled out in Excel. And the x sub ij's, there's a position there for all of them, so they're spelled out. The y sub i's, they're spelled out. What I need now is to spell out the demand restrictions. So go back to the expression here for the demand restriction, and let's put that into Excel. I have 5 of these equations. So for j equals 1, 2, 3 through 5, I have one of these equations. Let's go back. So I could write it in as equals demand in market j equals 1 minus the sum of the production over all plants eventually will equal 0. See, right now I am not meeting demand because I haven't produced anything. There's no production occurring. But the constraint says that when I'm done, this number that's now 12 should be 0. Now if I put that in correctly, I should be able to copy that formula across all markets, and I want to check it. So I'm going to push F2. Notice that that's 12 minus the sum across all production. I'm going to move over to the next one. That's 8 minus the sum of all production in South America, across all plants. And I could just keep going to make sure that I've hit all of the 5 constraints. Now we've got to put in the other constraint. The other constraint is this capacity constraint. It's a little more difficult because of this y sub I right here. But let's walk through this. So here we go. Let's put in capacity constraint. It's equal to capacity, so low capacity times y sub I for the low capacity. So notice this is either going to be 0 or it's going to be 1. I don't know yet. Excel will help me choose. Plus high capacity times y sub I minus the sum. Now this time I'm looking at a particular facility across all markets. So the production in North America cannot add up to more than the capacity in North America. I close that off, and I can copy this down that row. Okay. And then I can check. I checked using F2, just making sure everything is highlighted correctly. Notice how I'm just kind of walking down one at a time. So now I have an explicit cell for absolutely every constraint in my math. The last thing I need is the objective function. So the objective function is the cost. So here we go with the cost. I'm going to take the sum of the product, so sum product of all of the fixed costs, and the fixed cost will only exist if we open a plant in market I. I'm going to add to that, well, what if I have something that's high capacity? So sum product, the fixed cost from the high capacity, and if I have that open, the fixed cost will add in. Close it. Now I need to put in the variable cost. Sum, plus sum product, all of the C sub ij's, comma, all of the X sub ij's. Okay, I have now completed the statement that captures total costs. Now it's time to use the solver. So I go to Data, Solver. I need to set the cell where the objective function lives. In my particular case, that's cell C36. I am minimizing. It defaults to maximizing. So if you have not gone through this problem once before, the default is to maximize. In fact, why don't I delete these so that you can see me enter them one at a time. Okay, so what can Excel choose? In other words, what numbers can it change? Well, the decision variables are the numbers it can change, which is why I'm highlighting all of my decision variables, all of my X sub ij's, all my Y sub i's. That's what Excel is allowed to play with. Well, then I'm going to add in the constraints. So let's go adding in the constraints. Add one. Let's see. Let's put in the demand restrictions. Here's the demand restrictions. All of those have to come out equal to 0. Add it. I have all of my capacity restrictions. All of those have to come out greater than or equal to 0. Add it. All of my non-negativity constraints. All of my decision variables have to be non-negative, greater than or equal to 0. Add the last constraint. All of my binary variables have to be binary. Okay. Now, here's my list of constraints. I have all of them listed. I should be able to now go down here and say select the solving method. It defaults to the GRG nonlinear. We don't want that. We're using this simplex. Simplex is a methodology created way back in the 1950s for solving linear programming problems, which is what the LP stands for. I should now be able to push solve. Excel does some work and it pops out the minimum cost of producing for each of my markets. Now let's do some interpretation. I'm going to keep this solution. Let's do some interpretation. Notice it did play around with these zeros. They're not all zeros anymore. This says that I'm going to produce in South America 20 units. Okay, I am hitting my capacity constraint because I'm building something with a capacity of 20. 12 of those units are going to North America. 8 of them are staying in South America. I am producing a large facility in Asia as well. And notice that all 20 units, the capacity, 4 of them are going to Europe, 16 of them are going to Asia. Finally, one more large facility, high capacity, I am producing in Africa, 17 units. So I am not I'm not hitting my capacity restriction. I am actually 3 units away from hitting my capacity restriction. So I'm only building 3 facilities. So for I chose I equals 2, 4, and 5 as my locations for facilities. Because of that choice, I will expect a cost of $23,751. So there you have it. This is how you use the solver, and this is the solution to this problem. Now you might want to use a variation of this in order to solve problem 1 in the home.